We are about to take you on an aerial tour of White Sands Missile Range. We are leaving from Condren Field at the south end of this 100 by 40-mile installation. Of more than 500 operational sites, we'll get a look at some of the typical ones. This is Condren, point of our departure. Only a few miles away is the Army headquarters area. Missiles displayed here have been or are being tested at White Sands. In this area are the Army's principal administrative and technical facilities, including laboratories, shops, and missile assembly buildings. These facilities are supplied electrical power, high-pressure air, and other services designed to meet the special needs of missilery. Nearby is the post housing area containing over 800 modern units. Here, the large buildings at center and in the foreground are well-equipped Army barracks. This is the Sea Station Complex, control center for tests originating on the southern half of the range. Here are located radar, telemetry, and flight safety facilities. Close by are 3 ANFPS-16 instrumentation radar stations, part of an extensive chain system covering the entire range. This is Army Launch Area Number 1, historic site of American missilery. From here were fired the captured German V-2s and prototype versions of many Army missiles. Here is the principal Navy launching area. Coming into our field of view is the massive concrete blockhouse, the AIRBOYD launch tower in the background. Rockets fired from this tower have contributed much to our knowledge of the upper atmosphere. This launch area was originally used to test the Redstone missile, the vehicle which thrust America into the age of space. Here, radars of the Nike Hercules system are tested. The large radome houses a powerful acquisition radar for detecting small targets at extreme ranges, including air-to-surface missiles. The smaller radars are integral parts of the Nike Hercules system. They include acquisition, target tracking, and missile tracking radar. This Hercules firing pad is an Army Launch Area Number 3. These bunker-like structures are for live storage and assembly of the Army's Nike Zeus anti-ICBM missile now under development. Much of the testing and evaluation of this weapon has been conducted at White Sands. Extremely powerful radars acquire targets for the Zeus missile. In the foreground is the transmitting radar. In the background, the receiving radar, 110 feet high. This is a Nike Zeus launch facility. From here, the first Zeus prototype was fired. Since then, this has been the scene of many successful firings of later versions of the missile. For example, surveillance radar makes sure that the skies over White Sands remain clear of aircraft during test firings. This is the small missile range, where extensive test data have been collected on such missiles as Little John, Red Eye, Mauler, and Missile A. Within the boundaries of the range lies White Sands National Monument. This is the Park Service headquarters building. In the background is the beginning of the large area of snow-white sand dunes. 45 miles uprange from White Sands Army headquarters is Holloman Air Force Base. Here the Air Force tests a variety of missile systems, as well as conducting the extensive aeromedical research necessary for man's continuing venture into space. This is King 1 site in the Holloman area. Here is located the main control center for tests conducted on the northern half of the range. At Holloman, an Air Force high-speed sled track determines effects of extreme acceleration and deceleration on both men and missiles. surrounding mountains are sprinkled with stations for gathering missile test data and for control of test events. This Sacramento Peak station monitors radio channels for prevention of interference with test operations. On Tula Peak, a telemetry station receives data transmitted from flying missiles. As many as 100 channels of information can be received simultaneously, covering a multitude of missile functions. At Phillips Hill, there is another chain radar station. Control of all radars in the system is passed instantly to that station receiving the best missile position information. A considerable amount of instrumentation is located at North Oscura Peak. The tower in the foreground marks the site of another frequency monitoring station. At the crest of the mountain, radar and other instruments are located. Here, as at most highly elevated sites, microwave relay stations assure line-of-sight communications. At the northern boundary of the range rests Stallion Site. Here are concentrated many kinds of range instrumentation, including two ANFPS-16 radar stations. These precision instruments can track objects hundreds of miles away. In fact, one modified FPS-16 at White Sands is a part of the Project Mercury satellite tracking system. This is the Search Site Surveillance Radar Station, part of the system which keeps craft clear of the range during missile firings. Also located in the Stallion Site area are various types of highly precise photo-optical tracking instruments. At Zerf Site, Nike Hercules missiles are launched from uprange. This is Salinas Peak, almost 9,000 feet high, the main communications center for the range. On Skillet Knob, a tracking telescope records missile attitude and event data, information not obtainable by other means. Optical data have proved especially valuable at White Sands, where most days are clear and cloudless. This is Harriet Site. Here are located a tracking telescope and, in a specially constructed building, a cinetheodolite. Elevating the instrument alleviates the adverse effects of surface air turbulence upon photography. This drone target has landed in an ancient lava bed, creating a difficult recovery job. A major advantage of an overland range is that missile parts and instruments can be recovered for engineering study. This completes our brief tour of White Sands. We have seen but a sampling of the natural and man-made resources, making this national range invaluable to our missile and space programs.